Assalamualaikum everyone. Welcome to our channel, The Atomic Mind. Today our topic is the Newton's second law of motion. By the end of this topic, you will understand what Newton's second law means. The formula if F is equal to ma. Apply this law to real life situations, and it will be able to connect everyday motion, vehicles, sports, and more. Start with a quick recap. In our last lecture, we talked about Newton's first law, the law of inertia. It told us that objects stay still or keep moving at the same speed in a straight line unless a force acts on them. But how much force? What happens when we do apply a force? That's where Newton's second law is. Now, what is Newton's second law? Newton's second law tells us exactly how an object will move when a force is applied to it. In simple words, the bigger the force, the more the object accelerates. The heavier the object, the harder is it to move. Now let's break this down with the real famous formula. The formula is F is equal to ma. What the formula means? F is equal to force measured in Newton, m is equal to mass measured in kilograms, a is equal to acceleration measured in meter per second square. Force is what causes things to speed up or slow down. The heavier something is, more mass, the more force you will need to move it, and the more force you apply, the faster it accelerates. Let's discuss some real life examples. Example number 1 is pushing a shopping cart. When you go to a mall for shopping, you pick up an empty cart. It has light mass and you push it easily. It speeds up quickly. When you pick up objects and your cart is full, it has heavier mass. You need to push harder to get the same acceleration. Means more mass is equal to more force needed. That's F is equal to ma in action. And the example is a car versus a truck. When you push a small car, it's easier to push. When a loaded truck is pushed, it's a way harder to move the truck. The truck has more mass, so it needs more force to achieve the same acceleration. Example number 3 is a children's swing. Push a child gently, they will swing. Push harder, they swing higher. It means it will achieve more acceleration. Same mass but more forces is equal to more acceleration. Let's discuss some misconceptions about this concept. Many people think force causes speed, but it's actually force that causes acceleration, a change in speed. If you are pushing a car and it's moving at a constant speed, you are not accelerating it. Only when its speed changes, force is equal to mass into acceleration applies. Let's understand with it many experiment. Let's imagine you have two toy cars, one empty, one loaded with weights. Push both with the same force. Which one speeds up faster? The lighter one, obviously, because with same force, less mass is equal to more acceleration. This simple demo help us see the law in action. You can do this experiment at home. Take two toy cars. Uh, one is empty, and on the other one put some heavy weights and do this experiment. Now calculate it with mathematical example. Let's, for instance, mass of an object is 2 kilogram and it acquires acceleration of 3 meter per second square. What is the force? Use the formula F is equal to ma to calculate force. Mass is 2 kg and acceleration is 3. 2 into 3 is equal to 6 Newton. So you need a force of 6 Newton to accelerate a 2 kilogram object at 3 meter per second square. Now reverse the situation. If you apply a 10 Newton to a 5 kilogram object, what will be the acceleration? So we arrange the formula according to acceleration because we have to calculate the acceleration. Now the formula will become A is equal to F and M is in multiply with acceleration. If it goes to the other side of is equal to, it will be in divide. So the formula become A is equal to F upon M. Put the value of F, that is 10, and the value of M, that is 5. 10 divided by 5 is equal to 2 meter per second square. So the acceleration will be 2 meter per second square. Let's link it with the first law of motion. Remember, if no force acts, nothing accelerates. as it was as in the as per, according to the Newton's first law of motion, an object at rest stays at rest unless acted upon by an external force. Means there, if there is no force, there is no motion, no acceleration. If no force acts, nothing accelerates. That's Newton's first law. But if you want to change the motion, apply a force, and now Newton's second law takes over. Let's have a quick recap on our Newton's second law of motion. Newton's second law tells us how objects change motion when a force is applied. The more mass something is, the harder it is to accelerate. The more force you apply, the more it accelerates. The formula was force is equal to mass into acceleration. Now I have a question. Please answer it in the comment section. I will be happy to read your comments. Question is, if a 3 kilogram object accelerates at 4 meter per second, what force is applied to it? Give me answer in the comments. You can easily calculate in the formula F is equal to mm. My second question is that what happens to an acceleration if you double the mass but keep force constant? Give the answer in the comments. I will be more than happy to read your comments. Number 3 question is, which needs more force to speed up, a bike or a bus? I am waiting for your responses. Please update me in the comment section. Wrapping up, Newton's second law is not just physics, it's everywhere. From your morning run to the engine in your car, every time something moves up or speed up, F is equal to ma is at play. In our next lecture, we will dive into Newton's third law, one of the most powerful and fascinating idea in science. Till then, take care. Goodbye.